Testing. Yeah.
Okay.
Okay, you guys are
Oh, yeah,
good.
perfect. I have to.
See ya.
All right, see you. Thank you, Jack. All right, let's get started.
Okay. Awesome.
So, slideshow, perfect.
Awesome. All right. Hey guys. So I'm Sam. This is Michael. We are here today to talk about all the ways your wonderful side project can get hacked, and all the ways that you can fix them. On. So first, some admin stuff. If you want, you can if you have Docker installed, you can visit this repository on GitHub, clone it, and if you have Docker installed, you can run it and test all the exploits out for yourself. That we're going to be showing today. It's going to link to a very, very secure, very, very, very safe web app that you can exploit. Okay, moving on. So, what's today's agenda? We are going to be covering three main exploits, all encompassing, all within, all really about injection of malicious code that will interfere with the operation of any web application. So we're going to be covering cross-site scripting. We're going to be covering SQL injection and command injection into the operating system, and we're also going to be giving you some resources on what you can find out and more stuff that you can learn. So, so some of you might be wondering, hey, this is a developer workshop, right? This is a dev fest. We're not here to talk about security. Why is it important? So, a lot of things. What you need to remember is that in the future, if you do get a job as a software engineer, you are going to be working with code that other people is going to be using. And it is your ethical responsibility as the maker of that code to make sure that the code you write is safe and secure. Because any mistakes you make are not just going to affect you, they're going to affect other people as well. So it is your responsibility. And it's just basic human integrity to be responsible for your code. And on top of that, any mistakes you make are going to cost your employer or yourself, if it's a self-hosted project, time and money to fix those. So you need to make sure not just that your code is functional, but that your code is safe. Right? So for example, this is this is what can happen if the code you write is not safe. This happened to me literally yesterday. So the background is that U of T uses an external auditing firm called Ernst & Young. Ernst & Young uses a third-party software called MoveIt, and MoveIt actually has a vulnerability in their code. And some malicious third party actually came and hacked them, and so they may have leaked my personal data as well as other students' personal data. And these are the consequences of bad code. So it is your job as a software engineer, not just the security engineers in your company, but also your job as a software engineer to make sure that the code you write is safe and secure. So before we actually get started on the exploits, we're going to take you through some basic security concepts. First up, the CIA triad, and no, this is not the Central Intelligence Agency. It is an acronym. It is short for confidentiality, integrity, and availability. So this is a basic model that it is a very basic model in cybersecurity that states that allows you to model your code and see whether it meets these three basic functions, these three basic targets, I guess you would say. So confidentiality is pretty obvious. Is your user data protected from other people, from other users, from attackers? That's one. Secondly, is their data trustworthy? Can they trust the data they put on the site? Can they trust that if they entrust you with their data, will it be tampered with? Is it safe from being tampered with? And lastly, availability. Will my users' data be available to them when they need it? That means if they need it, will my service be able to provide that data to them in a timely and effective manner? So you will notice that a lot of modern attacks usually target one of these three. So for example, data breaches, confidentiality, data tampering, that's under integrity. So or even website defacement, like when a hacker finds an exploit that exploits the HTML that gets served to your browser. That's under integrity. Availability. DDoS attacks. So some script kiddie with LOIC, which is a DDoS tool, can easily attack if someone with an LOIC can easily attack the server. That's your code is no longer available. Moving on. So the second thing is the OWASP top 10. So OWASP is short for the Open Web Application Security Project. It is an organization that seeks to promote web application security. And every year they compile the top 10 classes of attacks that happen to various web applications. So you can see it's a whole list. These are not their own. These are not individual attacks. These are whole classes of attacks that can happen. And today we're going to be focusing on injection attacks, as you can see. And yeah, I'll leave it Michael to continue.
All right, so what we're going to be covering today is essentially white box penetration testing. And so what this essentially means is that you're doing a penetration test with access to source codes. And so I guess before you like what is a penetration test? Essentially, it's testing like a web application or a piece of software for like security flaws. And typically there's like two ways to go about this. There's like white box and there's black box testing. So white box, you have access to the source code, and it's generally a more comprehensive penetration test that can identify hidden internal risks, whereas black box testing, it more so attacks the application from the perspective of a like total third party that has no knowledge of the internal workings of the application. So yeah, so an example of like white box penetration testing would be like if you're contracted by a company to take a look at their internal software and conduct a penetration test that way. Whereas black box testing would be something like bug bounty hunting. So going on like HackerOne.com or Open Bug Bounty or whatever, and finding these like websites that offer rewards for finding bugs, but they obviously don't give you access to the source code, but you're able to perform a black box test on their servers. All right, so we're going to be covering cross-site scripting as the first of three injection attacks. Yeah. So what is cross-site scripting? This is essentially the injection of malicious code into a website that gets served to front-end users. And so there are security mechanisms to protect against this, such as content security policy and the same origin policy, which is the default security policy on most browsers. And these can mitigate these attacks by restricting where executable code can be retrieved from on the internet. So let's say you're on google.com and somebody injects a malicious script that fetches a JS file from their like attacker server. Google's content security policy would disallow that script inclusion. So yeah, in essence, runs arbitrary code. The impact could be the theft of user data or sessions, so you can act as other users. We'll show an example of how this can be done later on with an example website. And it can also be used to deface websites, which is, I guess, less exciting. So yeah, there's two types of cross-site scripting. Well, technically there's three types, but there's two that are that we're going to demonstrate today. The first is reflected XSS, which is triggered by the server reflecting user-provided input back to another user through the browser. So an example would be a payload through a get parameter. So let's say you're on the google.com and you have a search query, and that search query is reflected in the browser, and it contains like an HTML script element. And if that gets included directly onto the page, that can lead to arbitrary JavaScript when executed. And there's also stored XSS, which is persistently stored on the backend server in like the database or in a file somewhere. So an example of this would be JavaScript added to a ticket, profile, comment, or other pages that are stored on the server and can be delivered to clients without the attacker doing much more work. All right, so yeah, we're gonna get onto the demo. So real quick, we're gonna showcase this web application we built real quick. So just started, I think.
You want to start it? Oh, unmute it. Okay. Oh, you can restart it. Right. Okay, start. We can control from here. It's fine.
All right, perfect. Okay, so this is the super secure library. It's a vulnerable web application. You can access it if you go to this link right here on the GDSC GitHub. I'm just going to copy this into the chat so everybody has access to it if you're curious, but it's not necessary. We'll be demoing it here. So this is the super secure library. We can see that when we browse it, we have access to a search bar. We have access to listing of books. We can search for books. If we go to this community stories tab, we have the option to upload stories with some text fields, which is worth looking into, which we will. Then we also have a login and a logout form. So, all right. So whenever we're testing for cross-site scripting, typically the payload that you would use would be something along the lines of script alert 1. So if we hit enter, we can see that the application shows up like this alert box with the text 1, which clearly shows that we can execute arbitrary JavaScript on the application, which is very dangerous, right? So as we can see here in the URL, we have an instance of a search term get parameter with a script tag included. And this is what gets rendered onto the web page. And that's what causes the arbitrary JavaScript to be run.
Show them the code.
Yeah. So in order to fix this sort of bug, we have access to the source code here. So that's where like white box testing would come in. So we can actually find the root cause of the issue. So if we find the search books endpoint, we can see that what it does is it fetches books from the database, and then it renders a web page using a template engine called EJS. If you're not familiar with this, that's all right. I'm somewhat new to it as well, but if we go to this EJS file, which is a template, we can actually see that here, that search term is getting rendered on the page. So there's two ways to include templates in an EJS file, and there's one that's safe and one that's like very unsafe. So the safe way is to use this this template where we have, sorry, this is the unsafe way, where we have a hyphen after this bracket and percentage. The safe way is to include it like we see here with an equal sign. So naturally, this is like a common mistake that can happen. So you need to understand how your template engine works in order to be able to use it safely. And if that's if you're using a template engine, if you're using something more complex like React, it'll be safer because I believe React has some built-in protections that just make it difficult for you to inject like raw elements into the page. So
another thing to add is that even though you're using React, something like React that may have inbuilt protections, it is not, that doesn't mean you're by default protected. So it's always good. We will give you some resources later for you to keep up to date on what sort of vulnerabilities you might find and how you can counter them.
all right, so if we refresh here, so once it what? Sorry, just waiting for the web server to boot up again.
Did it restart?
Yeah, I need to restart it.
Yes, you can clear the lights off.
Okay.
Awesome. Okay.
So sorry, do you guys want the lights on or the lights off? Off? Okay.
It's gonna take a second. Okay, here we go.
This is why Node will never be subject to race conditions because single thread.
Well, I have one that's like a web browser.
All right, so look at that. We use the same payload, but this time EJS was able to put that like text with like the script tag onto the page, and it properly escaped it. So we can take a look at the page source to see exactly what it did. If we look here at the search result, we can see that it used HTML entities to encode those special characters, and so there we go. It protected against that XSS attack. So next, I want to show you like a really practical example, because once you get like JavaScript running on like a client's browser, like where do you go from there? Like what's the actual security implication? So on this website, we have guest users and an admin user. And the way that you log in as the admin user is by visiting this login page. And so I know the admin password, so I can just log in here. And we have access to this like admin dashboard, right? Now, what we can do is if we can inject like any HTML in general, we can actually provide a payload that sends the administrator's session cookie to us, which we can then use to get access to the admin dashboard without having to authenticate. So for this case, I'm going to use a website called webhook.site. And this is just like a website where you can send a request and then you can view all the requests. And we're going to be just fetching the admin's cookie this way. So I've actually prepared this payload here. I'm just going to show you what it looks like. So essentially, so this payload here is an image tag, and it has this onError attribute, which will execute this JavaScript. It will basically fetch this webhook URL with the document.cookie, which gives us the session cookie. So I'm just going to go ahead and copy. Actually, I think this is already correct. So if we just hit.
You need to.
Sorry, I need to make it vulnerable again. My bad.
How should I show the effects after?
Yeah.
Sorry, it takes a while. It's done.
All right.
Can reload.
So now if I reload, yeah, now it's vulnerable again. Okay, so I can go to this like admin browser, and if I visit this URL, nothing seems to happen. I have this like image, right? That isn't loading. But if I go here, I get like two new requests, one from this browser, one from the other. But this is the relevant one. Here, we can actually see that we have this connect.sid session cookie with a value. So what we're going to do is just literally open up our developer tools, and we are going to paste this cookie into this connect.sid cookie. So now if we go to login, sorry, let's see it correctly. Oh, wait, I'm not logged in right now. Oh, I think, sorry.
You need to retrieve that. We get the cookie again.
All right, so, oops. I'm just going to go here. I'm going to execute that payload again. And now I have a new.
Yeah.
And if I paste that cookie value into the cookie now, and I go to login, I have access to the admin dashboard without entering the password on that first browser. So that's sort of the practical application of XSS. But as I said earlier, there are protections against this. So in case somebody is able to inject XSS on your web pages, you can have like a content security policy so that they can't fetch scripts from other sources.
So this is an example of reflected XSS, right?
Yeah, this
Yeah,
is reflected.
so stored XSS basically is sort of the same thing, but instead of the data getting reflected back immediately, it actually gets stored in some sort of database. So when the web app loads that, then the malicious code gets rendered as HTML. So that's where you would usually target a user, for example, that's searching for a certain item. And that code can be anything. So it can even it can spawn like a malicious iframe from which you can launch further attacks, steal credentials, steal data, for example. So yeah, XSS is very malicious and very insidious. And major companies are susceptible to this sort of thing as well. I think Zoom got hit with a CSRF vulnerability once as well at one point, at the height of the pandemic, which was when everyone was using Zoom. So
Yeah. So these are more like client-side vulnerabilities. So they're sometimes considered like low-hanging fruit, but we'll get to more severe ones next. So yeah, this is just a note. When I was like just preparing this web application, I was asking ChatGPT about like template engines and specifically EJS, and it gave me this like totally wrong response, telling me that if you use this template, then you're properly escaping user provided input, which isn't the case because we demonstrated that you need to have the equal sign instead of that hyphen in the template to properly escape user input. So yeah, just be careful. That's why you need to know what you're using. All right, so next.
Yeah. So next we're going to cover SQL injection. So if all of you are web devs, who here is a web dev? Raise your hand. Okay, so those of you who have worked with web dev will probably know what SQL is. So for those who don't know, SQL is because we have people listening online as well. So SQL is a language that allows you to interact with databases. It allows you to extract data from databases. It provides a bunch of commands and ways to filter data, ways to sort data, bunch data together. So SQL injection works in the same way as a cross-site scripting would do. You have a form on a web page, and you insert malicious SQL, malicious payload that basically runs commands that the programmers did not expect on your database. So the ramifications of that are data deletion. This is a very famous XKCD comic. And here you can see that is the classic way. That's the classic payload on a SQL injection. On a SQL injection attack. So here we have Robert. That's the son's name. Closing parentheses. Drop table is a SQL command. Students is the name of the table. And then the dash is actually the start of a SQL comment. So how most SQL injection vulnerabilities occur when the text is not properly escaped. So for example, you do select from table students where something, and then you would have a string plus your input string plus and the rest of the command. That is very unsafe because then the server will treat that whole string, the database will treat that whole string as a query or a SQL command, which means you can inject a command like that drop table into what was meant to be a query, and people lose the data. You can do other things as well. Select from table admins, for example. So that's why in the end says, I hope you've learned to sanitize your database inputs because that is how you protect against SQL injection. So what is the SQL injection attack? The set is it exploits a lack of user input validation and filtering to modify the SQL query that was intended by the original developers. So they can include additional SQL commands or even replace the original SQL command by commenting. So inbound SQL injection is the most common. Attackers will usually use the same channel to send and retrieve the query. So the query gets rendered onto the screen. Attackers can retrieve or manipulate data And they can craft a payload such that we can execute commands on the remote server. So here's the demo. Michael will do this one.
All right. So just wait for this to. Oh, perfect. All right. So as we saw earlier, like in the search parameter, what the backend does is it actually fetches these books from a database. And so if we take a look at the source code, index.js search books, we can see that we have like this pull.query call here. And the content inside this is a SQL query. And this is a select query, which essentially means that it's fetching data from the database from the books table. So as we can see here, if you're familiar with JavaScript, you'll know that this is string interpolation. And so what happens is this search term, which is fetched from the client, is directly plugged into this SQL query, which is very unsafe because this doesn't have any escaping or filtering or sanitization involved. So if we just go ahead to this search, we can craft like a payload that'll crash the query. If you just put like a single quote here and we search, we get like this internal server error, and we can actually just go ahead and view the logs here, and we can look at this last statement, and we can see that this results in a syntax error, and Postgres doesn't like that. And so we can actually see that this apostrophe or the single quote just got plugged into that search term string interpolation bit. So you can execute more complex attacks. Like you can just straight up fetch data from the database using like a more complex query. So you could do like this would come with just like testing the application and seeing like how many columns it's fetching from the database and what are the types of those. We're not going to get into detail with like how to go about doing that, but for the sake of this demonstration, we're just going to say that we know like how to fetch.
So
Data from
basically,
here.
what he's saying is that what happens at first is that you can do some sort of reverse engineering. Try some payload, and if you get something, then iterate on that payload until you find something that works. Basically,
Yeah. So it's a
yeah.
whole process.
Yeah.
So yeah, as we can see here, we're able to like fetch, but by like adding on to that SQL query with a union, which essentially like bunches together data, we can add the admin username and the admin password here. And so yeah, that's very dangerous. The way that we can fix this is to
Parameterize.
use parameterized queries. So we're using Node Postgres, and in Node Postgres, the way that you would parameterize queries is by making the query use like these indexes, which start at 1, and then supplying your search term as an additional array. So if we
Is Postgres index for one?
yeah.
Okay.
Wish there was a faster way to do this. Actually, I just wanted
This
to
is what you get
docker.
for running Node.
Yeah.
Shit, that's what.
One free to mobile right now.
Okay, I'm free into it. I don't know what.
I don't know. I should have done that. What?
Is it up and running?
No.
No.
When I was at home, it would happen like so quick.
The thing is, you have to like book it, release it, and
Yeah, and then just
book it
install it.
so you don't have to release it caches being stored.
Yeah.
So you only have to install once and then you restart it. And then install it.
All right. So yeah, now when we search for it, we don't get any results because it's not executing that payload insecurely anymore.
So basically what happens here is that now that we parameterize, we no longer, we are no, so now that we parameterize it, Postgres is no longer treating your payload as part of the command. It's treating it as an input to the command. So it escapes it by default. A lot of SQL libraries will have this sort of feature. It's called a parameterized query. Most SQL libraries will have some sort of way of making parameterized entries so you don't accidentally expose yourself to a SQL injection.
So there is another avenue for SQL injection here, and that's on the login page. So if you take a look at the source code, and we go to this like login endpoint, we can see that when we send a login request, the same thing happens. We make a select query to the users table, and we just see if this user exists in that table. And we use that just string interpolation again, which is insecure. So if we can craft a payload like admin or true, and then have like a bogus password, and then we'll get authenticated without like actually entering the proper, like the admin's password. If we go to make logs, okay, never mind. I actually don't print out the query, but the way that it looks like is if we did like, if username is equal to admin
And true.
or true. So essentially this is like saying, it's basically like fetching all of the rows in that table.
And because it executes username admin or true, it automatically evaluates true, so it will just return you everything. Basically.
So you don't really need to include a username. All right, so the way that you would fix this, same way, is parameterized queries.
I think we need to restart for this one.
Yeah, it's fine. And then you would just include username, password. And so yeah, this is safe. Yeah, to demo it.
So we're not going to do that because this is the last demonstration, but you get the idea.
All right, back to the slides.
Okay,
All right, so the final thing we're going to cover today is probably the most severe vulnerability, and that is command injection. So how does this work? It works the exact same way as like XSS or SQL injection. It's an injection attack where user input isn't properly validated or sanitized. But yeah, it's more severe. So this essentially allows the attacker to execute arbitrary shell commands, which can lead to privilege escalation and possibly like just total server compromise. It can impact server integrity and availability. And yeah, for this, if you're ever going to be executing shell commands in your like web application, you need to be sure that you're doing so safely.
So I know a lot of you, probably none of you use PHP anymore, but PHP has a specific shell command that allows you to execute shell commands in the browser. And it is very, very important, especially in PHP, that you make sure you bypass, you filter and validate the data so that the text actually gets used as text and not as a command. And the reason why shell command injection is so insidious is that, as Michael said, it leads to privilege escalation, because once you find a shell injection vulnerability, you have access to the operating system on that server. And if that operating system has a privilege escalation vulnerability, you can get root. And once you have root, so root is a super user that has total control every single privilege on the system. And once you have root privileges, that server is going down. So just to give you an idea, if any of you have used Linux or any Unix system, you would have heard of sudo rm-rf/ yes, root users can do that. So that basically, for those of you who haven't used Linux, that deletes your entire file system. So that's why shell command injection is so malicious, and it's very, very dangerous.
All right, so yeah, we're going to move on to the demo. So we can see that in this community stories tab, we have the option to like upload a file and just add these fields. You can browse, add this like docx And if we upload it and just wait like 30 seconds, hopefully less, um, it'll essentially create like a story in the database that has a link to a PDF file. So what's happening here is we'll have a docx that's being converted to a PDF. And the way that this application performs that is by using a shell command. And so that's something that we're going to look at in just a second.
Takes a while.
Let's take a look at the source code. So we have this upload post parameter, which is where we're actually sending this file. And so we can see that it finally finished. And so we have this like PDF, coolstory.pdf that was converted from docx. So taking a look at the source code, we can see that, okay, we fetch these fields from the request, we fetch the file name, and then this command seemingly uses this file name in the command directly using string interpolation again with no filtering. And so we can actually confirm if we go up to the Multer configuration, which is where we, Multer is a module in Node that we can use to have like accept uploaded files basically. Where is that? Yeah, here. The file name is just the original file name of the file. So basically what happens is the raw file name gets used in that shell command without sanitization. So before we go any further, I just kind of want to demonstrate what a Linux like subshell is, which is what we're going to use to execute arbitrary code by changing the file name of that docx file. If we just add another command within these backticks, we can basically execute any like shell command that we want within another shell command. So if we do here, we do echo and then echo test within these backticks. We get tests. We can like echo ls, and then we get like the ls that gets echoed. So what we're going to do is something that affects the availability of the server. We're going to change this file name to a shell command that kills the node process and will like make the server unavailable. And of course, like you can do way more malicious things than this, but this is just a demonstration. You could create a reverse shell so that you can actually interact with the server and execute commands like more conveniently for yourself. Yeah, we're gonna have this pkill-x node shell command, which just kills the node process. So let's try that again. Okay, upload that, and we can see that immediately the server becomes unavailable. And if we just try to visit, like it's not coming on because we killed that node process. So we can actually take a look at the logs from the server, and we'll see that node accepted this sigterm signal, which is just a Linux signal that essentially means like die.
Yeah, it's a signal that the OS sends to the program to tell it, hey, it's time to stop, basically.
So that's how you execute arbitrary shell commands in this demo at least. So from here, how do we go about fixing this? So I mentioned Multer earlier, right? And this like file name function here, we can essentially, when Multer accepts an uploaded file, we can configure this so that it sets the file name to be something that is sanitized, and then save that on the system. So in this case, a good way to do so would be to use like date.now, and that'll give us like a Unix timestamp, which just has like numbers and nothing malicious and has nothing to do with the original file name. And then we can just add like the original file name's extension. All right. So now, if we bring it back up, and it'll take a second. We're actually good on time.
Honestly, yeah. That's something for it.
I really hope that there are no audio issues on Discord right now.
We still have the same audience, so it's all good. Just don't join it. Careful.
Okay.
I can check.
Yeah, you're right. I should have cached.
So heads up, you guys have like
So yeah,
10 more minutes. Is that fine?
yeah. So basically,
All right, so yeah, we're back now, and that issue should be fixed. So if we upload this same file with that shell command, and we upload,
Okay, basically, what happens is
okay, I made a typo, X name, whatever. I'm not going to go through that whole thing again, but essentially the concept, right, is that you, instead of using the original file name, you would instead use something that has no like dangerous characters or special characters like backticks or dollar signs or whatever. And so yeah, a good way to do that is to use date.now. You can also use a UUID, which is universally unique identifier. That just creates like a random like number basically.
another way would be to use regexes, for example, to find and replace any malicious characters. So yeah, you can just use a regex, find and replace, remove any malicious characters you have typed. So any shell characters that you may see, just remove them. And there are other ways to do it as well, as you just showed.
Yeah.
Okay.
All right, so
just demoed it.
yeah, moving on. So we're going to cover some examples of these vulnerabilities, XSS, SQL injection, and command injection that were found in the wild on real websites using like black box testing. So these are essentially like bug bounty hunters that are reporting vulnerabilities and have decided to publish them.
So this is on a website called HackerOne, which is about a bug bounty website. It's actually a very good way to make money. If you're able to find bugs. And yeah, you get paid if you find a bug and report it.
Yeah. So this particular bug, it's an arbitrary command execution, which is basically what we just did. This got awarded bounty of $2,500 because it's like a very severe vulnerability. So yeah, there's like scaling. XSS isn't worth much. SQL injection is worth more. Command injection or arbitrary code execution is probably the most severe thing. So there's a lot of technical details here, but if we go to the meat, which is this screenshot right here, this shows the this shows the vulnerability in action. So this is like a proof of concept of how you would exploit this vulnerability in, I believe it was Kubernetes. So there's this HTML header here called CMD, and then it hosts a command ID. And then in our response here, we actually get this command executed. So we can get the ID of the www data user on this server. So that's basically what we did, except we didn't like retrieve data, we just killed the server. But this is totally possible as well. And so yeah, $2,500 for command execution. Very severe vulnerability.
Also, if you see, it close, but you may have caught on the side here, something, CV and a long string of numbers. Bear that in mind. We'll be covering that later.
All right, so this next one is a blind SQL injection. A blind SQL injection is another form of SQL injection. What we covered was something called inbound SQL injection or in-band SQL injection, which essentially means that the way that you retrieve data, it comes through the same channel that you requested. So we sent a search term that was involved in a select query, and then that response was rendered on the same page. Blind SQL injection works a little differently in that the response from the server is less verbose, and so sometimes you won't even get any output that changed, like on the front end. So you might not actually get like the admin and a very secret password displayed on the front end. But what you can do is use things like timing-based SQL injection to sort of like brute force your way into determining what certain values are. So yeah, in this case, this user found a blind SQL injection in InDrive. They were awarded $4,000. And this is essentially where that payload is. This is a demonstration of that payload in action. So that's just basically the same thing that we did. This is just or 1 = 1, and then a SQL comment, which just gets rid of the rest of that SQL query. All right, so the last example here is XSS. And yeah, this is like, you'll recognize this payload. This is like very similar to the payload that we used earlier. So we declare like a source that's incorrect, and then we have JavaScript that's embedded in this onError attribute. And that will essentially render some text on the screen in an alert box. So that's a demonstration of XSS. And this one was used on a big website, so I guess that's why it's awarded so much. All right.
All right, so we're reaching the end of our presentation. We hope you took something away from this. So here are some resources that you can use to find out more and learn how to protect you and yourself and your own projects against this sort of thing. So we have something called the Common Vulnerability Scoring System. So that is a system for rating the severity of various various bugs and various vulnerabilities in web applications, not just web but also desktop applications, software, that sort of thing. You may have seen on the side various severity levels that it follows that scheme. So there are certain criteria that a bug needs to meet before it's classed as something like that. Next is OWASP that I told you about. Every year, OWASP releases a compilation of the top 10 classes of attacks that work on various various web applications. They also have a security testing guide. It's open source, so it's free and open source. You can access it online. You can read through that to learn how to test your next few projects. OWASP also operates a bunch of chapters around the world, so you can go to the website and look for where your nearest chapter is and maybe join it. Next is CVE. So CVE is a database that is built and maintained by MITRE. So MITRE is a security corporation. It has funding from the U.S. Department of Defense. Sorry, no, not Department of Defense, Department of Homeland Security. They get funding to maintain this database. It is one of the biggest and most comprehensive databases of various vulnerabilities that have been found. So normally what happens is when a bug bounty hunter or a penetration tester finds a vulnerability, what they will do is they will report it to the company that created a product that has the vulnerability. And once it's been patched, they will then submit it as a CVE to the database. I am actually personal friends with someone who has a CVE to the name. It's considered a bit of an achievement in your career to have a CVE to your name. So if you find maybe if you're using a tool that you want to check the security of, you can go to the database, you can search up the name. There are vulnerabilities. It will give you a very, very scary idea of just how many vulnerabilities there are, because humans make mistakes, humans program stuff. There are going to be vulnerabilities in anything that people make, anything that you make. which is why it is so important to be responsible for your code and to be aware of the consequences of your code. Next, if our talk has gotten you interested in what else there is, because these three exploits that we just showed you are not the only ones. You have cross-site request forgery, you have a whole bunch of other exploits that you can do. So if you're interested in web security, you can try penetration testing. You can install something called Kali Linux. Some of you may have heard of it. One of the tools on it called Burp Suite, or another one is called Metasploit. These are tools that penetration testers use to pen test, that real security professionals use to pen test websites, web applications, and various other things. Other resources include Hack the Box Academy. Hack the Box is a penetration testing website. It's like a CTF. So CTF is like capture the flag. It's like a hacking competition basically. Where it's basically how quickly can you get to root access on a certain machine. They have a spin-off called Academy that basically trains you in the tools and skills that you need for this sort of thing. The last one is a bit inaccessible. It's Offensive Security's Web 300. So Offensive Security is a company that offers the very, very prestigious Offensive Security Certified Professional certification. It is very expensive, but it is also very prestigious. And it is pretty much a requirement for any high-level security professional job. They offer another course called Web 300. It is very expensive, but it's honestly a good thing to have if you're interested in being a web security professional. So yeah, that's the end of our talk. Thank you very much. Any questions? No?
All right. Thank you for coming.
Just one thing, if you're interested in tea, if you like tea, we have tea in the DH cafe, so
Stop that.
come on down, DH, let's go, get some tea. We love tea, right?
All right. Thank you guys online for coming.
You repeated the word T so many times that